I think it's time to start another large project that's probably going to take a year or more. Um, and what I always wanted to do is I always wanted to build myself a computer from, well, starting with the processor and then adding some memory chips and just building yourself a computer, making all the circuit boards and that sort of thing. And because modern processors are really far too complicated and convoluted, and you couldn't do that nowadays. And um, then again, making your own processor or building a computer from TTL, that's also really fun. But for now, I think I'm going to stick with a pre-made processor. Um, Sort of out of the first generation of, well, the first or second generation of really integrated processors that you could buy on a 40-pin dip. So what are our options here? We could use the, I'll just bring this in focus. Someday I've got to get a new camera mount. We could use the Intel 8080. This one is made in 74. And that would be a good choice. The issue with this chip is it needs multiple power rails and it needs biphasic clocks and whatnot, and it's quite limited in other ways. And there's also, it's a little harder to find reference designs. And since I've never done a homebrew computer, maybe I'll do another one with the Intel 8080 because I really want to get this into a computer, but I'm not confident enough to tackle a project like this. So another very classic choice would be the 6502. This one is second source made by Rockwell, but original Mostec, I think Mostec made them. Ones are incredibly expensive today, but there's plenty of second source ones. So you could do 6502, and this is actually something that I considered a little longer than the Intel 8080, and this is definitely something that's doable. It's done before in modern times by plenty of people. And I think I still might do that someday, but not today. Today, we're going to use an absolute classic processor that's been used in many commercial products and computers for many years. And there's still plenty of stuff based on the architecture. It's actually a derivative of the 8080, and it's the Zilog. Wait, this is the Zilog Z80, and I also have one made by a Zilog Z80 CPU made by ST here. Got both of those, and I think I will base my project around the Z80, mostly because I never had a Z80 computer when I was growing up. I had a Commodore 64, and so it had a 6502 processor, and I've never done anything with the Z80, and I think it will be lots of fun, and also there's plenty of reference designs out there. The architecture is fairly easy to understand, all kinds of things. It only needs a single supply rail, single clock, which is great. Yeah, so I think I will use probably the ST one, because that one goes up to, I think, 8 megahertz or something. I have to read that up. This is a 4 megahertz Z80. And then what's also interesting, I also just found in my pile of early computer chips, these are East German clones of the Z80. Although I think this is the CPU, and these are actually serial I/O chips. So we might also give this a shot once we have the computer build up. So what else are we going to need to build our computer? We're going to need a processor. I'm just going to let's stick with the Zilog for this overview. And what do we need in a computer? We need some memory, some read-only memory preferably. And I am likely to go with something like this. This is an SGS Thomson 2764 64K erasable programmable read-only memory. It's one of those that you have to stick into a UV chamber to erase them, but that just, I think, makes it a little more period correct. Although I'm going to break with this very, very soon when we come to the RAM. So I either use this, which is 64K, or if it turns out I need more memory, I might use one of these. These are made by ST, I think, fairly recently, and these are actually 2 megabyte chips, which is horrendous, and we'll never use that much. But they're 8-bit addressable, so the memory I don't need, I can just leave those address lines, basically untouched. And this is not very period correct. You wouldn't have had memory this large, or possibly even this large. You would have probably stuck with something like this. This is Russian made EEPROM, which is actually, I think, was made later or at the same time, but these are 2K memory, so you would need a lot of them, and you would string them up in a sort of row, and have some address decoding, so the right address points to the right place, and but I think I'll have this, or maybe use this. I'll not be using EEPROM, like electrically erasable PROM. That's just to make it a little more period correct while not being period correct. And the same actually goes for the RAM chips. I'm going to use these RAM chips. There's a lot of focusing going on today. There we go. Which is the HM628128 ALP, which is a fairly large RAM chip. Back in the day, you would have used many tiny, either static RAM or even dynamic RAM, and you'd have a whole huge board of them. But I really don't want to do this, because there's really nothing you learn from it and you gain from it, just besides making yourself miserable. The reason for designing a computer like this is to actually learn something and to have some fun. And while others say, yeah, it's fun laying out 20 billion RAM chips and 20 billion ROM chips and whatnot, for the time being, I'm not going to do that. I might do that at a later point, but for now, I'm going to stick with those huge modern static RAM chips that make design a whole lot easier. And what do we need in a computer besides that? We need some serial I/O. This is the Zilog serial I/O 2 chip, support chip for the Z80. I might use that, or I might use the East German clone, or I might use, this is the Z80 CPU again, I grabbed the wrong chips. I might use this is also serial I/O 2. Okay, these are the same, but I also have some serial I/O 0 and serial I/O 1 chips. I don't know which of those I'm going to use. So that gives us some memory, some RAM. We've got a serial interface on our computer, and from there we're going to go forward. But the thing I really want to do is I want to make this expandable and upgradable and changeable. So I'm going to start with the most basic system I can imagine that we still can connect to via terminal or something. Or I don't just want to build a thing where you have a hexadecimal display and you enter your data with switches. That front panels are really cool and the blinking lights are fun, but I think I'm going to design this in a way that you can actually connect a terminal to it over serial. And from there I want to expand this, and my end goal is to have, well, a processor, RAM and ROM. I want to have a serial interface. I want to have some sort of mass storage. This could be, then most likely will be either a hard disk, a very small old hard disk if I can scrounge up some, or maybe a floppy drive, or a tape drive, or a cassette deck, something like this. I want to actually go in and design the circuitry to make this work, which in my opinion is a lot of fun. Other people might think otherwise, but I think this is a lot of fun. And I also want some parallel I/O. There's also a chip called the PIO for the Z80 that just gives you parallel I/O. And to that, we might connect all sorts of things. I don't know, displays or whatever. That is going to be fun. And to actually start with just the Z80 and the RAM and the ROM and the serial, and to add stuff later, I think the best thing would be to have this all on a bus, or a huge backplane sort of thing, where just all the stuff is broken out, and then you can have your cards and you can stick them in and you can design new cards if you want. So what I basically want to do is to have something like this. I'll just shove all the chips to the side. Something like this, where you have power going in here and have a little power lid, and then just all those parallel lines where you can put your address lines and your data lines and your system control lines. And if you have your processor card here, you can stick whatever the serial card in here, and then you can do your address decoding on your card. And so your address decoding is completely independent of what's happening here on the processor card. You can just, if you wanted to add something else, you can just stick a card in here and do the address decoding right. So if you're going in here, it goes to your cassette deck or whatever. And I think I'm going to do something like this. And I'm not sure if this is a wise choice yet, because these pin headers are, well, I had some bad experience with those and high clock rates. But what I want to do is basically have a circuit board with female pin header like this. And then you could have an angle pin header from your card Just grab a piece of circuit material from somewhere around. There we go. You can have your card with an angle header that goes like this, male angle header, and then you could stick it in like this, and then you can have it sitting here, and there's 2.5 centimeters in between here, so you have plenty of space to put your chips and whatnot. And I think this is something that I'm going to try, although I'm going to suffer greatly when drilling all those holes by hand. This is set up for 6 cards with 40 pins on the backplane. It's going to be a quite serious amount of work to get all the holes drilled and have all this sorted up. Although the PCB design wasn't that hard at all. It's just straight lines. So that is, I think, the plan for now. And also, I thought about how to supply this with power. And what I came up with is I'll just have this sort of wooden board. I'll put some 3D printed feet on it soon. Sort of just glue there so it sits up from the table a little bit and doesn't weeble around. And then I'm going to have my computer sitting on here. I've still got some space out the front for I/O or whatever, and might even put this whole thing in a case later. And to generate to supply it with power, I'm going to hold the whole system down to just a single 5-volt rail, because I think that is easiest. And we're going to generate, if we want to do RS-232 serial, we're going to generate our negative rails for this on the serial card from the 5 volts. Maybe using something like a 7660 voltage inverter chip, or we could use something like the Max 232 or Max 202 that just does this internally, although this brings us further away from period correctness. But I think this is something that is still acceptable to use. It's not like we're sticking a Raspberry Pi in to do our bus control or something like that, which I've seen people do, which I don't necessarily approve of. Or using an ATmega to do the address decoding or something like that. Yeah, although you still might learn a lot. It's not my style, really, of doing things. So I've got a single 8-volt transformer here. This is going to have plenty of power to supply this. The whole system, I think, will use less than an amp, but we'll design it for 2 or 3 amps at 5 volts. And that should give us plenty of overhead and wiggle room to. So this is an 8-volt transformer, which is a bit high, but will be fine. At 1 amp, we're going to dissipate 4 watts, which should be just about fine. And because at the moment I plan to have this open and accessible, so you can stick your fingers in, I designed a little hood that just sits over the transformer. So nobody can go in here and stick their fingers into the 230 volts and electrocute themselves. Because we always have to design things for the people that live around us. And I definitely know you shouldn't stick your hands in there. And I think my wife also knows that she shouldn't do that, but then you have friends over and they go, oh, look at this cool computer thing, and they're sticking their hands there and they die, and you just don't want that. So, little hood goes over here, makes everything nice and safe. And so we need to, first, as always, we need to design a power supply. And I think I'm going to use something like this. which is a TO3 free terminal voltage regulator. It's just a 7805 in a huge chunky package, but this is rated a little higher than the 7805. I think this goes up to 2 amps, although I have to test that. Because the datasheet specifies that it only goes up to 500 milliamps, which I find hard to believe, given how massive this package is. So we're going to have this on a little heatsink, maybe standing off like this from here, or maybe we'll put it over here, I'm not sure yet. Although I'd like to be a bit conservative with the space on here, so I can, I don't know, put some displays or something in here. Not sure. First thing we're going to do is design ourselves a power supply, although this will be subject of the next video. I'll try and keep those videos at about 25 minutes each, so they're okay to watch. I personally find it hard to watch 2-hour videos, and these videos are always sort of a progress report. What did I do since the last video? What design? Whatever. So that's, I think, all that I wanted to say for now.